mass of A is equal to mass of B. Say that's M. So this has a coefficient of friction mu. Now at T equal to 0, the block B is at rest, whereas A is given a push or an impulse, because of which it has a velocity v0. Then after some time T, the velocity of A is, let's say, v1. The velocity of B is v2. So we have to express v1 and v2 in graphs. Okay, so what will happen is that immediately at T equal to 0, if you see the FPD of A, because of the relative motion, the slipping, which is occurring in the forward direction on it. So there will be a kinetic friction acting like this on it, which will give it a deceleration like this. So you can see this much. Okay. So the deceleration of A is mu g. Whereas at the same time, if you look at the free body diagram of the Planck B at this instant, at T equal to 0, and this all we are seeing from the ground frame. So even though this is at rest, this experiences friction because on top of it you have something which is slipping. So this gives it a forward acceleration. This also has an acceleration mu g but forward. So this continues also for some time. So at some time T equal to T, if VA is still greater than VB by that time, so still the free body diagram should be looking like this. This is moving with VA. This is moving with VB. VA is equal to V0 minus mu GT. VB is equal to mu GT. But suppose VA is less than VB. So at this point of time, there is still slipping occurring. So friction is acting like this. But at T equal to some other time T prime, let's say, if VA has become equal to VB, then the relative motion ceases. So kinetic friction stops acting. So at that point of time, let's say this becomes the final velocity. Okay. So this becomes uniform motion from here. We can even find that final velocity because V0 minus mu g t prime would be equal to mu g t prime. So that time will come out to be mu0 by 2 mu g, and therefore this final speed will come out to be V0 by 2. Okay, so Srijit, I hope this is clear up to this point. So now we have to just understand how to relate this with graphs. Okay. this whole situation, we have to relate it to corresponding graphs. You can see that if you look at the graph of each speed with respect to time, it decelerates for a certain amount of time and then becomes uniform. When it becomes half its initial value, it's okay. Whereas if you look at B's velocity, it accelerates for that much time, 0 to t prime, and then becomes uniform at the same value, the final speed. Okay, so that is this particular question. So Srijit, I hope this is clear.
Yes, sir.
Okay.
Sir, in which cases would the other graphs apply?
Sorry, in which cases
Would the other graphs apply? Like the D1?
like the graph in D?
Yes, sir.
No, that kind of situation will only happen when there is friction on the floor. There is friction on the floor, and plus what is happening is that, yeah, I mean, friction on the floor, and that too in such a way that, no, that is actually not possible, because if the coefficient of friction on the floor is very less, okay, so then initially B will still accelerate because the friction acting from above will dominate over the friction acting from below. You understanding the point with that?
No, sir.
Okay, there is a question in HC Verma in kind of in friction chapter, in the absolute last question of friction. Okay, try that question out, then you will understand how that option D will work. Okay.
Yes, sir.
Okay. So next question is a Newton's laws problem, which does not involve friction. So I'll complete these type of questions first, because still have your MT coming up. It still will not have friction. We'll have only up to Newton's laws of motion. Anyway, this question involves a bit of calculus application. So what is happening is that we have some kind of a coordinate frame given over here, and with relation to that coordinate frame, we have some kind of a surface. It's parabolic in shape. and then eventually becomes a horizontal surface. So this surface, parabolic part, has an equation which is given to us. It is the curve y is equal to 2.5x square. Now on this there is spherical body kept somewhere over here, let's say. It's then connected by a cable kind of thing. And that cable is then going around. It's a massless cable or string kind of thing. That is then going around a pulley. So this is all arranged in such a way that this cable over here is at an angle of 60 degrees with respect to the horizontal, and E is at a point, is in contact with this at a point which has coordinates .4 meters. So if x is equal to 0.4 meters, you can see the y coordinate which is lying on that should be 2.5 into 0.4 square, which is also 0.4. So this coordinate is also 0.4 meters. Okay. So now we have to find, so 4 kg sphere rests on the smooth parabolic surface. Determine the normal reaction that exists on it on the surface and the mass of the block B to keep the system in equilibrium. Okay, so if it's in equilibrium, it's quite easy actually. So given that mass of A is equal to 4 kg, so we have to find mass of B such that the system is in equilibrium. And we have to also find the normal reaction acting on B. So the only thing that is tricky here is you have to find the direction in which the normal reaction acts. Okay. So for that, so yeah, can anybody tell me how I'll determine the direction of normal reaction acting on A? What is the direction of normal contact force? It is normal to the surface now. Yeah.
Yes, sir. Perpendicular.
So how will I determine that direction here? Plane
Yes, I
of
will draw
contact.
tangent.
Yes, very good. That's all you have to do. No? You have to draw a tangent at which point? At the point of contact, which has coordinates 0.4, 0.4. Okay. And then you have to draw a line which is perpendicular to that tangent, which is the normal line. So the direction of normal reaction will be that. So how we'll draw the tangent, or how we'll know the slope of the tangent? That's the calculus subject. Right? The parabolic curve, it has a function. No, y is a function of x.
Yes,
What
sir.
does dy by d is like? That is the slope of the tangent, no? At any given
Yes,
point.
sir.
Okay, so just use that. So try this, all of you. Try to determine the direction in which normal reaction will act on A with respect to the horizontal. Okay. Try to make the FBT of A, and in that try to understand. So the direction of normal reaction acting on A will actually depend on the direction of the tangent. And then from that you will determine the direction of the normal. Okay. So if A is lying on a surface like this, curved surface like this, and at this point of contact we have to first draw the tangent. So then the normal reaction acting on A will be acting perpendicular to that tangent. We acting along this line. Okay. So for that, to see that this tangent, so if this point of contact is P, let's say, okay, so that has coordinates 0.4, 0.4 in meters. Okay. So at the point P, okay, so slope of tangent in general is dy by dx. That is 5x. So therefore, at the point P, the slope, which is basically tan theta, where theta is this angle. So that is 5 into 0.4. That's 2. So now you can see that therefore the line that the normal makes with the vertical, this angle will be theta. So theta is tan inverse of 2. So that is the same thing as sine inverse of 2 by root 3 or cos inverse of 1 by root 3. Is this clear, Srijita?
Yes, sir.
Okay. So now next thing what you do is you make A's free body diagram. So understand that in A's free body diagram there is tension also acting. Okay. And there is normal reaction acting. And there is A's own weight acting. Okay, so these three forces only because there it's a smooth surface. Okay. Now see here that the tension is not acting parallel to the surface. Okay, it's acting in a different way. Tan inverse 2 will be greater than 60 degrees, because tan 60 is root 3 is 1.7. So notice that this theta will be greater than 60 degrees. Okay, so now make a free body diagram of A, and from that try to determine the value of tension. Okay, and then you realize that tension should be equal to the weight of B.
Yes, sir. Sir?
Sir, you are not audible.
Sir? Sir, can you hear me?
Okay, people. So one of the challenging things here will be to find the components of tension and all that. So that's why it will be easier in this case to resolve the forces instead of resolving along the normal reaction and along the inclined plane. It's better that you resolve the forces vertically and horizontally. I'll explain why. So this normal reaction is acting like this, whereas you will see that the tension is acting like sort of like this. The tension is acting at an angle of 60 degrees, the horizontal, whereas the normal reaction is acting at an angle of theta with the vertical, which is greater than 60. And of course, weight is acting vertically downwards. So weight is the mass of A is given as how much? 4 kg was it? Yeah, 4 kg.
Yes, sir.
So here it is easier if you resolve the forces vertically and horizontally. So what you do is the vertical component of N becomes N cos theta, which we saw is N by root 3. So this is the same as sine inverse 2 by root 3, cos inverse 1 by root 3. And the horizontal component of n is 2n by root 3. Then you take tensions components. So this becomes t sine 60. So root 3 by 2 t. And this becomes t cos 60 or t by 2. And you have weight 4g. So we have the relations that t cos 60 has to balance n sine theta, or t by 2 has to balance 2n by root 3. So t is equal to, or rather we can better substitute n as root 3 by 4 at t. And from the vertical equation we have n cos theta plus t sine 60 is balancing weight. So we have n by root 3 plus root 3 by 2 t is equal to weight. So this is our second equation. In this you substitute this. So this equation becomes root 3 by 4 t into 1 by root 3 plus root 3 by 2 t is equal to 4g. So it becomes t into 1 by 4 plus root 3 by 2 is equal to 4g. So 2 plus root 3 by 4 t is equal to 4g. So the tension in the thread becomes 16 upon 2 plus root 3 g. Okay. And then when you look at B's free body diagram, it's very easy to understand that tension is equal to B's weight. Okay. So from this you can see that B's mass is 16 by 2 plus root 3, which you can rationalize and write as 16 into 2 minus root 3 divided by 4 minus 3, which is 1. It's 16 into 2 minus root 3, or approximately 16 into 2 minus 1.73, or 16 into 0.47, so 27. Okay, so hope this question is clear.
Yes, sir.
Okay, okay, take this down.
Done, sir.
Okay. Okay, you want to complete this one. Just a minute. Just give you some more time to go through that one. Achha, to find the normal reaction also, you just substitute the value of tension that we've calculated in the equation, that N is root 3 by 4 times T. So okay, so done.
Yes,
All right.
sir.
Okay, so this is a question sent by Arushi. Okay, let's go through the question. We have to find that maximum velocity in terms of the given parameters, which are alpha, beta, and the time t. So what I would advise in a question like this is try to visualize the graph of velocity versus time, or speed versus time, whatever. So realize that the graph looks like a triangle, like the acceleration part is a straight line with a positive slope and the deceleration part is a straight line with a negative slope. So if you visualize the graph of velocity versus time, realize it looks something like this. Let's say it accelerates at a certain rate and then it decelerates faster or whatever. So the graph need not be symmetric. So this total time is small t according to what is given. Okay. And this has an acceleration of plus alpha here and it has a deceleration of beta here. So this is the maximum speed it reaches. So we have to find maximum speed in terms of the three given things, alpha, beta, and t. Okay, so try this out now. So hope you are clear with the graph that I've drawn, Arushi.
Yes, sir.
Okay. So there is one key to solving this question, and that is to understand this time in terms of the given parameters, alpha, beta, and t. The time at which it switches from acceleration to deceleration. Try to figure out how we'll get that time taken. From that, we'll get the answer. Okay, so you can see that this maximum speed So this maximum speed can be written as alpha t1, which is also equal to beta into t minus t1. So from this second equation, you can see that t1 can be written as beta upon alpha plus beta into t. So our Vmax is alpha beta upon alpha plus beta into t. Okay, so Arushi, hope this question is clear.
Yes, sir.
We'll come to another question. Let's go through this question next. So elevator is ascending at a constant speed of 10 meters per second. So ascending means it's going up. Okay. A constant speed of 10 meters per second. So its acceleration is 0. Now ball is thrown vertically upwards by a boy in the elevator. It should be rather than on the elevator. Anyway, when it is at a height of 40 meter, so the speed of projection of the ball relative to the elevator. So this UR is the projection speed with respect to the elevator. This is given to us as 30 meters per second. At an instant when from the ground level, the elevator or the ball or whatever he is throwing, that is at a height of 40 meters. This height is 40 meters. Okay, so as the ball goes up and comes down, the elevator itself will have vertical motion during that time. So we have to find this maximum height it reaches from the ground. So let's say this is t equal to 0. Okay, so the first question you have to understand here is that what is the projection speed in the ground frame? How much is the projection speed with respect to a person on the ground?
40 meter per second.
No, see, With respect to the elevator, it is 30, na? Sorry, it is 40, correct. So 40 plus 10, yes. So projection speed with respect to the ground is the sum of this relative speed plus V naught. So that's 40, that's correct, okay. So projection speed with respect to ground. So Arushi, you have understood this point, I hope, okay. This will
Yes,
be
sir.
U, so U relative plus the speed of the elevator. So it's 40 meters per second. Okay. So therefore now this maximum height it will climb to from where it was thrown. That maximum height, you can directly use the formula. So that's 80 meters, right? And therefore the maximum height from the ground, that is just equal to the initial height from which it was thrown to this max plus this maximum height. So it's becoming 120 meters. That's the correct answer. Yes.
Yes.
Okay, so okay, good. Okay, so next, so just make a note of this. Next time coming to your doubts, Om, which you have sent in WhatsApp. So have you people discussed something called virtual power method of constraint relation in pulley systems?
No, sir.
Not yet. Okay. Okay. So you will discuss that at some stage, and that will give you a more effective shortcut method of doing constraint relation in pulley systems, especially systems with lot of large number of pulleys. Anyhow, we will discuss by the normal calculus method. Okay, so without the virtual power method, this next question that we are going to do, it becomes a bit of a monster question. So we have this kind of a situation. Right. So we have this kind of a situation. Now the person above, what he's doing is that he's pulling the rope on both the sides with a constant speed u. Then we have to find the speed of the block. So this rope also is pulling at u. This rope also is pulling at u. So we have to find the speed of with which the block is going up. Find this. Okay. So what you first of all see is that these pulleys with respect to this level, let's say, they are all at a distance of, let's say, by b. Okay. And this pulley from here is at a distance of by p. So you can also see that this is equal to some h minus yp. So, okay, where h is this total distance. And you can also write this small distance from here to here as d. So how many different threads do you see in this home? How many threads are we using in the system?
Sir, I believe 4.
Why? How are you seeing 4 threads? Tell me. One thread is from his. There are 2. No? This is one thread. Okay. And this whole thing is one thread. No? See.
Yeah, sir.
So there are only 2 threads. So we have to
But sir,
conserve 2 threads.
on the left hand side, there is one more thread, no? Which is fixed.
Where?
Sir, on the fixed surface, on the extreme left, that
So
y
this
minus
thread,
h minus yp. Yes, sir.
right. So this thread is only going round this pulley, then round this pulley, then round this pulley. So this is all the same thread. This is the thread which is ultimately connected to his right hand. You see,
Yeah, sir. Okay.
एक ही thread, no? That's why. Okay. So that thread 2 only is this way. It's going from his hand, then round this pulley, then this. Finally, it's attached to the ground over here. Some point fixed to the ground. Okay. Okay. So understood this point now. There are 2 threads. Okay. All right. Now see what is happening. Thread 1, its length is reducing at the rate of u. Okay. So dl1 by dt is equal to minus u, because he's pulling the thread from this side at a speed u. And the length of the second thread is also reducing at the rate of u. Okay. Now let's write the expression for this. So you'll see that this pulley will be going up with some velocity, let's say vp. Okay. So from this you'll understand that vp is equal to u. And that vp is equal to minus d by dt of y. Is this clear?
Yes, sir. Sir,
Hmm.
so just wanted to ask that what is yp and yb?
Yp is the position of this pulley with respect to this ground level. You understand it? It's just this displacement kind of thing. The position vector. Is it clear? And yb is the position of the block, but actually the position of the pulleys which are attached to the block with respect to this fixed level of the pulleys. These 2 pulleys are fixed, no? This one and this one. You understand?
Yes, sir.
So with respect to that, these 4 pulleys are at a given distance of yb, let's say, at any point of time. And because they are attached to the block, so I have related it as b. Okay, is it clear now?
Yes, sir.
Okay, now see what is the total thread length for the second one. Okay, if the length on this side is s, it is that s, okay, plus this arm, which is D plus YB, okay, plus this plus this plus this plus this plus this. So there is another, so there are total of 1, 2, 3, 4, 5, 6, 7 sides. Okay, so one side is like this, then in between there are 5 sides like this, which are just YB. Oh, sorry, there are 4 sides which are just YB, and there's one more side which is so this side is, in my diagram it is looking like YB, but remember that this pulley is at a movable distance. Okay, so it is at
Yeah, sir.
YB plus D minus YP, that kind of, okay. And finally there's that smaller side which is at H minus YP. So this is the total thread length of
Sir,
this one. Yes.
what is D in that?
B is, YB is this distance. Now see, I've written in red.
Yeah, sir.
Okay.
So the D is the above part, right?
Any B is just a subscript beta. YB is the distance
Sir,
from
D,
this.
D.
D, acha D, D is this one. Yes, yes. D is this one. Okay, clear now?
Yeah, sir.
Okay, so let's work this out. So this is S plus 2D. Okay. Plus how many YBs are coming? 1, 2, 3. Oh, sorry, there's something wrong here. There should be 4 YB. The middle part. How many direct YBs are there? 1, 2, 3, 4. There should be 4 YB. So in all YB should come 4 plus 1, 5 plus 1, 6 times. 3, 4, 5, 6. Yes, it should come 6 times. Okay. Then there is so taking care of the YBs, and then there is minus 2 YP plus also this H. So I'll just keep the constants aside. These two are constant terms. S is variable, of course. Okay. So this is the length. Okay. So this thread length now is decreasing at the rate of, actually this is all fixed. Okay. So dl2 by dt is becoming, this part's differentiation is 0. So plus 6 times dy b by dt minus 2 times dy p by dt, and that thread length is decreasing at the rate of u. So it should be minus u. So is this expression clear now?
Yes, sir.
Okay. So now from this equation you can see that the rate at which yp is changing is minus u, and the rate at which yb is changing should be equal to minus of vb, because this is going up now, so yb is decreasing. So minus 6 bb, okay, minus 2 times minus u should be equal to minus u. So minus 6 vb should be equal to minus 4 u, sorry, minus 3 u. So vb should be equal to u by 2.
Sir, is this the answer?
This should be the answer. Let me just verify it once. Okay.
Actually, sir, we don't have any option such from the question.
But there's a none of these correct option, right? Just a second. Okay. 6 is acting on this.
Actually, sir, the answer is 3u by 2. I checked it below.
Just a minute.
Option B is correct, it is shown.
Okay, just give me a minute. I'll verify this once. Okay. Because this is a very lengthy way of doing the question actually.
Sir, can't we do it with pulley constraint?
Just hang on a minute. Huh? Just
Yeah, sir.
yeah, this answer is correct. It should be so you can check the answer once from whatever source you have of this question. It should be u by 2 only. And it should not be 3u by 2. Yeah, what were you saying? What other
Sir,
method?
is it possible to do with pulley constraint?
This is only pulley constraint. This method that we have applied is pulley constraint only.
Sir, but I think it is a differentiation method.
What differentiation? Beta thread length. So thread length conservation I have used here. There are two general methods of doing this. One is thread length conservation, which you are calling as the pulley constraint. In thread length conservation only, we use the differentiation, the rate of change of length of the thread, that concept. Okay. And the other is something called virtual power, which you haven't learned yet, but I have applied it on this side. Okay, and that is giving us the same result actually. So this method that I've used, this is only the thread length conservation method. I've used the derivative concept, the thread lengths are changing at this rate.
Okay, sir.
You understanding, no? Okay. So now there is also sort of ad hoc way in which we can do this question. We can understand that. So I'm just going to take this diagram. So if I want to understand this in a sort of more direct way, instead of writing the entire thread length and all that. Okay. So what we'll understand is that because he's pulling this with u from here, so what is happening? This pulley is actually going up at the rate of u only. This pulley is going up at the rate of u.
Yes,
Okay.
sir.
So if this pulley is going up at the rate of u and this block is going up at the rate of b, okay, then you can see that this thread length how it is changing, the second thread's length, how it is changing. So I'll start from the most left-hand side branch. Okay. So that left-hand side branch's length is increasing at the rate of u. Okay. Then the next one is increasing at the rate of u minus vb. Okay. Then the next one is changing at the rate of minus vb. Okay. This third one, then fourth, fifth, and sixth, and seventh. So the next 1, 2, 3, 4, 5 branches, they are changing at the rate of minus vb. Okay. So minus 5 vb. This is the net rate of change of length of this whole thing. So this should be equal to minus u because he's pulling with the speed of minus u from this side. So you can see that 2u minus 6 vb should be equal to minus u. So from here, 6 times vb should be equal to 3u. So velocity of the block should be u by 2. Understanding? So if this side is 1, this side is 2, 3, 4, 5, 6, 7, and 8. So this is the rate of change of branch 1. This is the rate of change of branch 2. And this is the rate of branch 3 to 8. So this is the net rate of change of the string that is holding on his right hand side. Okay, so the thread length method is clear for all of you. Yes.
Yes, sir.
You learn a method called virtual power later, where you'll see that in such a situation, the net power delivered by tension on the system should be 0 because tension is an internal force. Okay. But that you learn after discussing about power itself, power delivered by force. Anyhow, so I'm moving to the next question now. This is again a constraint relation problem. So this is a block that is sort of forced to move inside a channel like this. So you see that the angle that I have labeled over here, this is a variable angle. So at the given instant, it is 30 degrees, but this angle will be changing as the block A moves. Okay. Whereas this angle which is given in the question as 60 degrees. This is a fixed angle because this block B is moving along a fixed channel. If block B is moving like this, then A is moving like this and vice versa. Okay, so now it says that A remains in contact with the ground. VA is equal to 10 meters per second at the instant when theta is 30 degrees. So find VB. So what you can do here is, this is a fixed height, let's say h naught. Okay, this is also a fixed height, let's say h, and this is a variable length. Let's call this z. Okay, and this is a variable length. So let's call this x. So the total thread length is this quantity. It is the hypotenuse. Okay, here plus a fixed length plus a variable length. So now this is constant. So dl by dt, which is differentiation of this whole term, should be 0. Okay. Now here you can see that dx by dt is minus dA. And here you can see that dz by dt is plus bb. So just use the differentiation and chain rule of differentiation and work this constraint out. So solve that differentiation further by using chain rule, and then so you will see that you will get the relation that VB is equal to VA into root 3 by 2. Okay, so let's complete up this problem. So when you do the differentiation here, you can see, you can write this as differentiation with respect to x of this expression into dx by dt. Okay, plus differentiation of h, which is 0. So this will become like this. Okay. Okay, so hope this question is clear.
Sir, actually, sir, how did you get that dx by dt in the second step?
Chain rule beta. What I'm doing is, see, when I open this bracket, I'm writing differentiation with respect to time of x square plus h naught square plus differentiation with respect to time of h plus differentiation with respect to time of z. Now this term is 0, but here, see, I have to use chain rule now, because this is a function of x and I'm differentiating it with respect to time. So by chain rule, I can write it as differentiation with respect to x of fx into dx by dt. Understood now?
Yes, sir.
No, chain rule was basically this, na, that dy by dx can be written as dy by dz into dz by dx. Okay. So similarly, I can say that differentiation of some function with respect to time is differentiation of that function with respect to x into dx by dt. And here that function is root of x square plus h naught.
Yes, sir.
Okay, so hope this is clear. Okay. So people, with that, we will conclude today's doubt session. But of course, you have some more time in the week before, especially your advanced test, which will be on Sunday, because I think your mains is on Wednesday or something. So you can continue sending me the doubts, and I'll help you work out those questions, etc. Whereas we have our regular lectures in the various batches also. So in that, we will continue with relative motion in this week. Okay. So that's it for today, people. Wish you all the best. Thanks for attending. Have a nice day.
Thank you, sir. Bye, sir.
Bye.
Have a
Thank you.
nice day, sir.
Bye, sir. Thank you.
Okay. Bye.
Bye, sir. Thank you, sir.
Hi, sir. Thank you, sir.